Namaste, myself Shivanandappa H Doddagoudar. In this video lecture, I am going to take a BSc 5th semester Mathematics paper 3, Statics and Laplace Transforms. In that one, I am going to take some part of Laplace transforms. Okay, this is the session number 40. In this session, I am going to discuss periodic functions and examples. That means we can come to know the Laplace transforms of periodic functions and the examples on that one it is. Now, in the previous video lectures, we did the first shifting property, scaling property, and second shifting property and examples we did. Now, in this video lecture, I am going to take a Laplace transforms of the periodic functions. Now, first we should define what do you mean by a periodic function. A function f of x is said to be periodic if f of x plus t is equal to f of x for some positive integer t. For example, you know a trigonometric function sin x and cos x are the periodic functions of period 2 pi. That is, sin x plus 2 pi is again a sin x, cos x plus 2 pi is again a cos x it is. That is why sin x and cos x are the periodic functions of period 2 pi. Now, we have to find the Laplace transformation of the periodic function. Let f of t be a periodic function of period t which is greater than 0, then L of f of t is equal to 1 divided by 1 minus e raised to minus st integration 0 to t e raised to minus st into f of t dt. That means this you can take this one as a theorem it is. Now, Laplace transformation of the periodic function is this one it is. Proof. By definition, L of f of t is what it is, 0 to infinity e raised to minus st f of t dt. Okay, you can split it. That is equal to 0 to t e raised to minus st f of t dt, t to 2t e raised to minus st f of t dt, plus 2t to 3t e raised to minus st f of t dt, and so on it is. Now, keeping the first integral as it is, plus in the second integral, you have to put t is equal to u plus t, second integral t equal to u plus 2t in the third integral, and so on like that it is. Now, from that substitution what we can get, L of f of t is equal to 0 to t it is e raised to minus su into f of u du plus e raised to minus st 0 to t e raised to minus su into f of u du it is plus e raised to minus 2st 0 to t e raised to minus su f of u du. Now, from that substitution you have to calculate upper limit is what, lower limit is what, dt is what is, right, that one it is. In the first integral also you have to replace t by u it is. We can get like that it is. No doubt, in all these integrals, integration 0 to t e raised to minus su and f of into f of u du is common. In the first term it is 1 plus second term e raised to minus st, third term e raised to minus 2st plus so on it is. Now, the terms in the bracket on RHS are infinite geometric series, you know, sum to infinity of a geometric series with r is equal to e raised to minus st which is less than 1. Now, we can make use of sum to infinity of a geometric series, that is what it is, a divided by 1 minus r. Now, hence that bracket can be written as 1 divided by 1 minus r, r is e raised to minus st it is, then 0 to t e raised to minus st into f of t. That means in place of t I have taken, in place of u I have taken t here. Therefore, L of that periodic function is what it is, 1 divided by 1 minus e raised to minus st 0 to t e raised to minus st f of t dt it is. Now, the example on that one is find L of t. where f of t is this one, f of t plus 2 pi is equal to f of t. Okay, here f of t is 1, 0 less than t less than pi, minus 1, pi less than t less than 2 pi. F of t plus 2 pi is equal to f of t means, now this given function is a periodic function with the period 2 pi. Now see that solution is, the given function f of t is a periodic function with a period 2 pi. Now you can make use of that formula here, t is equal to 2 pi it is. You know the formula here, L of f of t is what it is, 1 upon 1 minus e raised to minus s t capital T, 0 to t e raised to s t f of t dt it is. In place of capital T, we have to take 2 pi it is. Okay, now that 1 divided by 1 minus e raised to minus 2 pi s as it is. Now 0 to 2 pi you can split it, that is 0 to pi and 0 to pi to 2 pi it is. It is there in the example itself it is. Okay, 0 to pi is 1, pi to 2 pi is minus 1. We have substituted that one is substituted here. Next step, you keep that 1 divided by 1 minus e raised to minus 2 pi s as it is, integrating e raised to minus s t divided by minus s, limits of integration are 0 to pi in the first integral, minus integration of the second function is e raised to minus s t divided by minus s itself, then limits of integrations are pi to 2 pi here. That outside bracket as it is, 1 divided by minus s as it is, putting the upper limit minus lower limit, we are getting like this. Here also upper limit minus lower limit, we are getting like this. Okay, totally it is that divide by s, we will write it as it is. Okay, and outside the bracket 1 minus e raised to minus 2 pi s as it is here. Okay, that means within this bracket we have taken LCM here. That means first we have to write this one is here, minus into minus plus 1, that one it is. Then e raised to minus pi s, minus e raised to minus pi s we are getting. Therefore, it is 2 times e raised to minus pi s plus e raised to minus 2 pi s as it is here is equal to, just you observe that numerator, it is of the form a square minus 2ab plus p square form. A is 1, b is e raised to minus pi s it is. That is what a minus b whole square. And in the denominator it is 1 minus e raised to minus 2 pi s is there. We can write it as a 1 square minus e raised to minus pi s the whole square. That is a square minus b square form. We can write it as a minus b into a plus b. Now, one a minus b term gets cancels here. We are getting 1 minus e raised to minus pi s divided by s into 1 plus e raised to minus pi s. That is equal to dividing both numerator and denominator by e raised to minus pi s by 2. This divided by s as it is, 1 divided by e raised to minus pi s by 2 is e raised to pi s by 2 minus e raised to minus pi s by 2 it is. In the similar way, you can get this denominator. Then divide by s as it is, again using the definition of hyperbolic functions. Now this is what it is. You can write this one as a tan hyperbolic pi s by 2 it is. That would be the answer for that example. Now in the similar way, try to solve these two examples here. Here in the second example, it is a periodic function with the period a. The third example also, which is also a periodic function with a period, what it is, pi, it is. Okay. Now these are the some multiple choice questions, and these are the some references here. Thank you very much.